Welcome back my dear friends and participants for this course multi-criteria decision making. A very good morning, good afternoon and good evening to all of you. And as you know, this multi-criteria decision making is under the NPTEL MOOC course, which is spread over 12 weeks, which is 60 lectures, and we are in the 9th week. And as you know, each week we have 5 lectures, each being for half an hour. Now, for the last 1 week or a little bit more, we have been discussing about the multi-attribute concepts, the non-parametric methods, and we had started about the TOPSIS method. Even though I have been repeating many things time and again, but once you understand the TOPSIS method, all other methods which we will discuss one by one, like the ELECTRE, AHP, Viacor method, will all flow in a very logical manner. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, this is the 43rd lecture. What would be the coverage under the broader umbrella of a multi-criteria decision making? We have already discussed multi-objective decision making. We are now into multi-attribute concepts and we were discussing about the TOPSIS method. By the way, as in the last class or last to last class, we have been discussing the methodology in the PPT and also giving the solutions in the Excel sheet. By the way, when I was discussing about the TOPSIS method, the concepts about PIS, which is the best positive answer, and based on that we find out the distance from the positive decision, and NIS, the negative one. Here in the slide, it will be done only, say for example, for the NIS, because the last ratio which we will be finding out, which I will come to that within few minutes, would be based on the NIS. But considering the problem which we were discussing about the housing, like the whole set of criteria. So, there were 4 alternatives and 11 criteria. The criteria can be divided into 2 different sets. One is, say for example, which accrue positive benefits, another which give you negative benefits, and we will basically analyze the problem accordingly. Now, in the coverage part you see that TOPSIS method is there, and I have also added the concept of elimination and choice translation reality, which is ELECTRE method. Why? Because once we finish in this 43rd lecture the TOPSIS method, we will immediately start with the ELECTRE method, and as usual discuss that in the slide as well as in the PPT slides and the Excel sheets accordingly. Now, if you remember, we are discussing about the weights, and weights are specific to the criteria. So, let me go back to the Excel sheet. So, the weights are given. Based on that, we had found the multiplying of the matrices, which was normalized of x, which we named as R, and the weights which we named as W. Based on that, we found V, and once V is found out, which is shown in red numericals in this set of Excel sheet, we find the maxima and the minima. The maxima and the minima based on the fact that we want to find out the best solution and the worst solutions accordingly, which will give us the PIS and the NIS. By the way, when I am talking about the PIS and NIS, remember, for the time being we have not differentiated into the subclass of the best set of criteria and not so best set of criteria. So, we find out which we closed in the last class, we find out the max and the minimum. Now, let us go back to the slide. So, the weights are there, they add up to 1, double check that, one should double check that the weights which are there because there are 11 criteria. So, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 criteria they add up to 1. So, weight would be 11 cross 11. Now, given this, I find out V, and V which you have found out, but remember the V which we are showing, and I was experimenting to show to you that different normalization will give you different matrices of V, but the general concept of trying to find out remains the same. So, as it was not possible in the slide, considering the whole set of V which you have is 4 cross 11, remember y 4, there are 4 alternatives, y 11, 11 criteria. Based on that, I find out all the values, and for your kind information, the values based on the concepts of the requirement which you want to find out, which is basically the matrix V multiplied by the weights, gives you a value which is specifically pointed out here is 0.021, which is the second row and the 11th column. So, that is why it is mentioned as V 2 comma 11. Similarly, if I want to find out the V 4 1, which will be V 4 1, that value is given by 0.0558. So, they have been calculated. Now, once we calculate, I try to find out the max value and the minimum value. Now, the max value and the minimum values are correspondingly found out, but now the issue is there. So, the max value and the min value which we have found out, I tried to show it along the corresponding column wise, but that was based on the criteria, but your actual idea is to find it based on the alternatives, because that is the final situation. So, if I want to find out the max, I am doing it in the nth and oth column in the Excel sheet, max for A means alternatives. So, I will mark it as A I, because there are I is equal to 1, 2, 3, 4, and then I want to find out min A I. So, I do it. So, I find out the max for the first, then I correspondingly find out the max for the second, max for the third, max for the fourth. Similarly, so I will mark them as yellow. Then I want to find out the min, so they are copied for the first, second, third, fourth. Again I mark it as yellow to make it highlighted. So, the max and minimum values are given based on the alternatives. So, given the values of V plus, we want to find it. If you remember, if you see here, the values are based on I is equal to 1 to m. So, I try to find out the maximum, and I will come to the minimum soon. So, based on the maxima, the first value correspondingly comes out to. So, obviously, you have to find it out. So, corresponding to that, for each I is equal to 1, 2, 3, 4, we find out the values. Now, the reason I am doing it along the row and along the column is based on the fact that how your representation of the rows and columns are. If the rows and columns are with corresponding to the alternative criteria or criteria alternatives, you have to basically interchange them. So, these are the case when the values are found based on the alternatives being along the rows, and these are the minimum values and the maximum values. Now, given that I find out the minimum. So, the minimum values are again for I is equal to 1 to m, same thing which we did, and the values are calculated accordingly, and that I am showing it in the Excel sheet. Now, comes you have to find out what is the solution based on the fact that what is the ideal solution. Now, here is what my repetition would be. Repetition is that based on the fact that how you have been able to divide the criteria into good or bad, we would divide into positive and negative. Here we are not doing that. I will do that within few minutes for the other methods also. So, once you find out the distance, now here important thing, if you find out the distance is given by L2 norm, we are just using the distance measure which we know. Now, the distance measures could have been L1, which is Manhattan norm, which is the mod, or else at the other extreme which could be L infinity norm, which is the max value. So, we will visit that for different sets of problems later on. So, once you have the V plus values, which are the positive values, so you find out the most positive ideal solution based on which I have x S I plus. S means based on the V matrix which I have, I will find out for corresponding to either the rows or the columns based on how the representation has been done. So, if I have the values, I find out S I plus, and corresponding in the next slide, I will find out the S I minus. So, S I plus is S I plus 1 plus, S I 2 plus, S I 3 plus, S I 4 plus. Why? There are 4 alternatives. So, the question would be, would we be able to find out correspondingly S I 1 minus or S 1 minus, S 2 minus, S 3 minus and S 4 minus? The answer would be yes, based on the fact we will find out the most negative ideal solution. Point 1. Point number 2, the question would immediately come up that as I find out the S I plus or S 1 plus, S 2 plus, S 3 plus, S 4 plus, for this case the distance concept which is found out is the simple distance norm. Do we still stick to that when we come to the negative calculation of the most negative ideal solution? The answer is yes. Once you decide on the distance norm, you will stick to that and follow it both for the positive and the negative. You would not change it in between. What you can do is that for each combinations of the length concepts like L1 to L infinity, say for example, you do it for L1, L2 and L infinity, you will find it both the S I pluses and S I minuses corresponding to these 3 L1, L2, L infinity, and then do the comparison, but do the comparison in the sense that the distance measure does not change. Similarly, coming back, we find out the most negative solution, ideal solution, and again see here the distance measure is based on the fact the L2 norm, simple case. The S I minus 1, S I minus 2, S 3 minus, S 4 minus, which are the most negative solutions, are given here as calculated. So, I have the most positive and the most negative. Now, what do I do with that? Now, based on that, we need to find out the relative proximity index for each alternative, which is was the problem to buy an apartment based on that criteria. So, based on that, I find out the relative proximity based on first the instance that I am only finding out the relative proximity based on the negative solution. Now, what would the negative solution mean? Negative solution would mean that for which distances I would not like to take those criteria in importance for analyzing the alternatives. Even if this is there, obviously, I will try to rank them as low as possible. Now, the question can be, is it always true that we have to consider only the negative set of criteria in order to rank them? Answer is no. You can also do it from the positive side, or else you can do it both from the positive and the negative and rank them accordingly. So, that means you are taking, when you are doing it from the positive and the negative side, you are trying to take a viewpoint where both the positive characteristics and the negative characteristics are analyzed in order to give you the best solution. If you are only considering the positive one, you will only consider the positive distance. If you are only considering the negative one, you will only consider the negative distance. But a rational method would be where you consider both of them and then try to analyze it accordingly. Now, here my earlier statement would be true, in the sense, if you remember, I did say that we can divide the criteria. We can divide the criteria accordingly and take the decision and break them up into 2 distinct sets of criteria and do this analysis. For the time being, let us consider that we are only concentrating on the negative ideal solution and doing the proximity analysis. So, the proximity analysis would be based on the fact that I take this ratio. The ratio is, I will use this red color, proximity ratio in the negative concept would be S I minus divided by Si minus plus of Si plus, which means that if it is the real line where we are considering, I have drawn it, but I will a few times I will again show it. My concentration is only on the negative one, which I am marking as red. So, any point Si which is there, I need to find out, and obviously there is a Si plus on the right hand side, which I will mark in blue. So, I will try to find out the ratio of the red line distance divided by the sum, divided in the denominator of the sum of the negative and the positive. Now, if the negative distance is 0, obviously the negative proximity would basically tend to 0, because in the numerator you have a very small value which can be taken as 0. If it is the red, the black point or the black decision, alternative is on the most negative one. Now, if it is positive, then obviously the other set of calculations will come up, which I will show within few minutes. So, based on that I find out the negative distances. So, these basically would be, if I write it with the coloring scheme to make things much more legible and understandable, I will use Si minus, Si minus plus Si plus. So, this would give me the negative concept. Now, if I want to do, so what is this? This is distance is here, distance is here, and distance is here. Now, if I want to do the positive sense, so I will erase it and come to that, write the formula. I erase everything, so that I can start afresh and do the calculation. So, those calculations are not shown here, they were only for the negative proximity. The actual diagram would be like this. This is the line, this is the negative point, this is the positive point, PIS and NIS. This is the point based on which we are trying to find out. So, that would be, because they are the alternatives, there would be 4 such points and we want to find it out. We would have basically the negative distance which I am marking in red, we have the positive distance which I am marking in blue, and the formula would be, I will write it down, it will be the ratio of Si plus, here also Si plus, Si minus. So, the minus goes here, and the plus concept comes here in the denominator and also in the numerator. So, obviously, the values would be calculated accordingly. So, if I want to find out the values based on the proximity in the positive sense. So, obviously, if Si plus, the distance is exactly on the and is 0 and the point is basically on the blue point, which means it is the best ideal solution. So, obviously, in that case it is furthest away from the red, because in that case black being transferred on blue, the distance between the negative solution and that alternative will be maximum. So, in that case Si's plus blue ones would be 0. So, and obviously, in that case the ratio proximity in the positive sense would be 0. Here in the other case it was negative sense, which was 0. So, you have to consider that in the negative sense is 0, that is worst, positive sense is 0, basically is the best, and you have to basically analyze the problem accordingly. So, this is basically the way or the you are looking at the problem and trying to analyze the result. Now, here comes 3 ways of trying to analyze. So, this the concepts which I mentioned about the proximity was for plus and minus. So, if I erase it, I will only highlight the one fact, and then logically the other ideas can also be extended. So, if I erase this, so I have in the negative concept the ranking as this, right, relative part. So, if I consider the relative ranking, then obviously it would mean in the ratio wise C1, which is for alternative 1, is about, I will only read till the first decimal, two decimal is 0.362, 0.23 for C2, 0.30 for C3 and 0.68 for the last one. So, if I go back corresponding to this, thus the ranking when I am trying to find out would be that if I have these ratios given as this is S4. So, if I find out the ranking, so this is the line, and the points are given. So, I will mark them one by one. So, 1, 2, 3, 4. So, the ratio for this case was about 68 or 0.68, which means if I am looking from the negative point of view, the distance between the negative one and the ratio is the highest, which means that it is more onto the right hand side. More 0 means onto the left hand side, which is the negative point. I am only considering for the negative side. So, technically this would be C4 because it is 68. Then if I consider, it will be C1, then if I consider, it will be C3, and last is C2. So, if I find out, it will be C4 is better than C1, C4 is better than C1, that is better than C3, and according to the ranking C2 is the so called the least preferred. So, if I write down C4 better or greater than C1, greater than C3, greater than C2. So, if I say this, the answers are C4, C1, C3, C2. So, C4, C1, C3, C2. Now, the question can immediately come up, fine, we have done it based on the negative part, what about the positive part, can we do that? So, let us do that in the Excel sheet and then rank them. So, I will take these values of Si plus and Si minus and do them. So, I will write S1 plus, S2 plus, S3 plus, S4 plus, and similarly I write down S1 minus, S2 minus, S3 minus, S4 minus. So, and here I will find out the ratios based on positive and negative. Negative positive means the NIS and the PIS concept we are trying to use. So, if I write down Si plus, the values are given, if you notice down, they are given in the denominator, the right hand side. So, I will write them accordingly 0.1045. So, then is 1543, 0.1543, next value is 0.0870, and the last value comes out to be 0.0425. So, these are all the positive part done. If I consider the negative one, so they are given as 0.0589. Negative does not mean negative value, they are based on the distance and the square and then square root. Then the value is 0.0477, 0.0477. Then I have 0.0387 and last one is 0.0928. So, all done. Now, I want to find out the negative and positive. So, let me put the negative as red in color and positive as blue in color. So, for I will not put the cells because then it will we will not be able to see it, so, and these negative being in red color, again bold. So, let us do it. So, positive one would be positive part divided by ratio of positive plus negative. So, I copy it. So, this is the positive one, and when I do it for the negative part is basically I am doing the negative divided by the ratio of the positive and the negative. And obviously, if somebody is interested, double check, the sum would be 1 because the ratios is what, the denominators are same, and one time you are taking Si plus, another case you are taking Si minus. Now, see, if you have noticed based on the negative how far it is, we had ranked them as this. So, I will rank them, rank positive. So, I will again mark it as blue, bold, blue. And if I rank them as just 1 minute, and if I rank them as negative, so this would be now bold red. Now, if I see it here, I will remove it once. So, if I see it here, so negative part was basically more negative it is further away. So, obviously, this becomes in the negative sense further on. So, it will be first, then we will come to 0.36 which is the second, then we will go into the third and the fourth. In the negative sense, you are doing in the opposite direction. Now, if I go into the positive direction, positive means the value, if it is 0, it is exactly on PS. So, I have to basically take the minimum value. So, this is 1 because that value is 0.31, then the value comes out to be 0.63, then the value comes out to be 0.69 and the value comes to be 4. Now, see the discussion here, and this is more of a discussion which we will analyze here. Now, if I consider all the 4 alternatives, in the benefit side, obviously, the ranking is always on the benefit side, which is based on positive. First I would have A4, I am putting them in this order. Then I would have basically A1, then I would basically have A3, and last would be A2 in a benefit side. If I consider the rank from the concept of the non-benefit, that means it is good that I have not taken that, or what is the least negative effect it will have, disbenefit. So, if I find out the disbenefit, again the red one, but on the other direction. So, obviously A4, then A1, then we come to A3 and come to A2. So, positive side, the ranking I will just mark, I will take few moments here. The ranking would be, I am using this, will go here, because and from the other side it will be just the other way around. So, I am using the blue color. Then if I consider the second one, it comes here. Then I consider the third one, it comes here. And if I consider the final fourth one, it comes here. And similarly, if I do the disbenefit one, let me remove the disbenefit. So, on the right hand side there is no crossing of the line. So, it becomes much easier for us. Let me put it side by side. So, symmetricity will give us a much better viewpoint. So, this was the answer. When I go into the negative part, I use the red color, but remember this ranking which I am giving the red and the blue are based on the positive and negative, but in the reverse direction. So, that should be important for us to remember. So, the first one goes here, and I am using the red color in order to specify. The second one basically is this, the third one is basically this, and the fourth one is again the same. That means, both in the benefit and negative scale and positive scale, I get the same ranking. So, there is no dichotomy. The question would be, it looks very straightforward, and obviously, this dichotomy should not occur, but there would be cases where you can have the dichotomy occurring, that when you are looking at the positive side and when you are looking at the negative side, your rankings may change. Now, one thing again I am mentioning, the ranking based on the positive and the negative are based on the fact that what are the distances. So, in the positive sense, if it is 0, best, and in negative sense it is 0 is the worst. So, you have to basically take the decisions accordingly. Again I am reiterating, I am only reading the decimal places. 0.31 is the best, so which is A4, then 0.63 is the second, which is A1, third is basically 0.69, which is A3, and last is A2, which is 0.76. If I look from the negative side, obviously the distances are 0.68 for the first, which is A4, then comes A1, which is 0.36, then comes A3, which is 0.30, and last comes is A2, which is 0.23. Now, so if you have only considered positive or only considered negative, the life would have been fine, but here I am trying to compare that how you can take both of them accordingly, depending on the set of criteria which can be divided into two sets. Now, the question may arise, are we able to replicate this concept of negative distance, positive distance for the other methods? In some cases, yes, and we will see that as in the discussion as we did in this lecture. Thank you very much and have a nice day.